In this video, we will be continuing with Part A, objective tests of the West African Senior School Certificate Examination Chemistry Paper 2. We'll be starting with question number 30, from 30 to 50. But before we continue with our topic today, I want to appreciate those of you who have taken some time to subscribe to my channel. But for those of you who haven't subscribed to the channel, please like this video, share to other learners, and most importantly, take some time and subscribe to the channel so that other soft papers, you will receive them. Thank you once more for taking your time to subscribe to my channel. Let's get started. Question number 30. Which of the following compounds has the lowest solubility in water at room temperature? Yes, you might not know which one is more soluble than the other. But using our solubility expression, product expression, which is this one here, we use for potassium chlorate, it is not like that. For potassium nitrate, almost the same. For sodium nitrate, the same. But the one that differs from A, B, and D is C. And if we use the solubility product expression for calcium hydroxide, we will have this. Calcium hydroxide, when it dissociates in water, we will have the calcium ion and two hydroxide ions. Now, in calculation, let the concentration of ions in solution be X. For each ion there, let the solubility be X. Then let's look for the solubility for OH ion. Therefore, the concentration of the OH ion will be equal to what? The concentration of the OH ion will be equal to 2 times X. Since the concentration, let the concentration of the ion in solution be X. Then the solution of 2 moles of hydroxide ion will be 2 times X. That is, it will be 2X. Now we want to use our solubility product expression for this equation here. When we dissolve this in water, what we are going to have, the KSP will be equal to the concentration of the calcium ion times the concentration of the hydroxide ion raised to the power of what? Raised to the power 2. But remember that the concentration of the OH ion is 2X. So substituting this value here, the concentration of ion is X. So calcium is X, and the concentration of OH ion will be equal to 2X squared. If we calculate all this, it will be 4X squared. So KSP, which is the solubility product expression, will be equal to 4X squared. And now, the solubility X is as follows. The solubility X for this very for this equation will be what? The solubility X will be equals to we will need to have, we'll divide both sides by 4, then look for the cube root, and look, dividing both sides by 4, and looking for the cube root, this value will be very, very low. This value will be very, very low. When we divide this, the KSP by 4, and look for the cube root of the product of the resultant here, the value, the X will be a very low value. That X being a very low value gives us, since X is the solubility. Now, it shows that the solubility of this very compound, it shows that the solubility of this very compound is very low compared to the solubility of the potassium chloride or potassium nitrate. Because the solubility of this, the KSP will just be what? It will be X times X. Because when they want to dissociate, we'll have potassium ion and nitrate ion, and it will take the concentration to be 1 to be X. It will be X times X, which will be X squared. And now if you want to look for the value of X, the value of X will be what? The value of X will just be a matter of, the value of X will just be a square root of what? The square root of the KSP. Unlike in this other case, the value of X is KSP divided by 4, and we look for the cube root. That shows that this one, calcium hydroxide, has the lowest solubility in water at room temperature. So our substance, the compound that has the lowest solubility in water at room temperature, is C. So we need to highlight our C. The value is C. Question number 30 is C. Okay, question number 31. Which of the following statement about the solution of hydrogen chloride in tetrachloromethane is correct? Hydrogen chloride in tetrachloromethane. Solution of this in tetrachloromethane is correct. It gives effervescence with sodium carbonate. It gives effervescence with sodium carbonate. It turns blue litmus red. Does not conduct electricity. Reacts with sodium to liberate hydrogen. Which of the following statements about the solution of HCl in tetrachloromethane is correct? When you put tetrachloromethane, when you put HCl in tetrachloromethane, HCl is acidic, hydrochloric acid, solution of hydrochloric acid. Solution of hydrochloric acid in tetrachloromethane. When you put it in tetrachloromethane, what happens? This is acid. If you put it in tetrachloromethane, what will result will be, what will be the reaction of acid on a litmus paper? It will turn a litmus paper, a blue litmus paper, red. If you put dilute acid in tetrachloromethane, because this is a solution of acid, dilute acid in tetrachloromethane, what will happen is that its action on a litmus, which is one of the tests for acid, it turns blue litmus paper red. So our answer will be B. Question number 32. Question number 32. The rate equation of a reaction arrow is equals to the rate constant concentration of X squared, then concentration of Y. By what factor would the rate of the reaction increase if the concentration of X and the Y are both doubled? Yes. If the concentration of X and the Y are both doubled. Remember, this is a rate equation. This is a rate equation. This is the rate. This is the rate which is equal to the rate constant, usually a value, times the X times the concentration of X squared. The value 2 there shows that X is of second order. Then Y is of one order. So they are telling us what factor, by what factor would the rate, what factor would the arrow, what factor would be arrow? What factor would be the rate of the reaction? Would the rate of reaction increase if the concentration of X and the Y are both double? We need to calculate this. Okay, you have observed it very well. This is the rate equation. This is how this problem can be solved. This is how the problem is solved. This is one of the methods. If you have another method, no problem. This is the rate, which is equal to K, which is the rate constant, times the concentration of X. X is the reactant raised to the power 2. That is, it is of second order. Then times the concentration of Y. Now they are telling us what factor, by what factor would the rate of reaction increase if the concentration of X and Y are doubled. Now, if the concentration, remember the square bracket are telling you the square bracket indicates what concentration. The symbol, this symbol, square bracket, shows that it is a concentration. So now let's look for a derivative of a change in the concentration. A change in this concentration. Change in the concentration of X and times the change in the concentration of Y. Now, the concentration of X now has been doubled. Let's put X to be 2. Let's put X to be 2. Now, the change here is the concentration of Y has been doubled. Let's put Y to be 2. Now, 2 times 2 is 4. Okay, 2 raised to the power 1 remains 2. So 4 times 2 is 8. So now our rate will increase 8 times. Our rate will increase 8 times. We will solve more problem on this, on how you can determine or deducing the rate and the order of a chemical reaction from the concentration. We are going to solve many more problems like that. Okay. If you don't understand this one, we will solve more. Once more, I said this is the rate equation. The square bracket indicate the symbol for concentration. Now 2 is the order of a reaction for X, and just the Y is the order of reaction is just 1. Then we are told that their concentrations are doubled. Then what will be the value of what will be the, if their concentrations are both doubled? What will be the concentration? What will be the rate? Now, the derivative for X, we will now say, we now substitute X by 2. Now, it will be 2 squared. Then times, we now substitute Y by 2, since all of them are doubled. So now, 2 squared will be 4. 4 times 2 will be 8. We now say that the rate will increase 8 times. And now let's go to our reaction column for 32. If we look at it for 32 and we see it there, then B will be our answer. B will be our answer. Now let's go again to question number 33. Question 33. Consider the reaction represented by the following equation. Potassium chloride, the equilibrium is potassium chloride plus 3 moles of oxygen. Which of the following factors would increase the rate of the reaction? Which of the following factors will increase the rate of the reaction? Okay, if you look at it critically, which of the following factors will increase the rate of the reaction? A, increasing the volume of oxygen. Increasing the volume of oxygen will not increase the rate of the reaction. Decreasing the temperature will not increase the rate of a reaction. Decreasing the quantity of the reactant will not increase the rate of a reaction. Addition of manganese 4 oxide or manganese dioxide or manganese 4 oxide. Manganese 4 oxide is a catalyst. If we add it on this, it is going to increase the rate of a reaction, but will not be used up, because at the end of the reaction it is regenerated. So D will be our answer. 33 is D. So manganese 4 will act as a catalyst for the decomposition. Okay, let's go for question number 34. Question 34. Question number 34. Question number 34. Which of the following have reaction? Which of the following have reaction equation? Which of the following have reaction equation correctly represents the electrolysis of a copper solution? Electrolysis of a copper solution. If you look at this one here, a copper solution. A copper solution, let me say a copper sulfate. A copper solution. Let me say a copper sulfate. Let me say a copper sulfate. When copper sulfate is dissolved in water, what happens is that it's in solution. What happens is that it will dissolve. We will have the copper ion and we'll have the sulfate ion, SO4 2-. Now the copper 2+ will go to the negative electrode, which is the cathode. The copper 2+ will go to the negative electrode, which is the cathode. And that is the cathode, the negative electrode. So what will happen here will be reduction. There will be reduction. This copper 2+ will do what? It is easier for the copper 2 ion to be reduced than to be oxidized. In other words, it is easier for the copper 2 ion to gain electron, and when it gains electron, it is reduced. Remember, this copper 2 ion, it is 2+, implying 2 electrons have been lost in the solution. 2 electrons have been lost. So it needs to regain back these 2 electrons. So it is easier for it to regain back these 2 electrons. And when it gains back these 2 electrons, it is reduced from copper 2 to 0. So the oxidation state of copper will be from +2 to 0. That is reduction taking place. Let's go back to our equation. Let's go back to our equation and see what is going on there. Which of the following half-cell equation reaction cell reaction equation currently represent the electrolysis of a copper solution. Copper plus 2 to give copper 2 plus. It's not possible because in solution it was initially 2 plus. So it need to gain back a 2 electron. So A is not appropriate. B, a copper solid will give out electron. It is not possible. Copper 1 plus. The most stable form of copper is copper 2 plus. So copper 1 plus is not good. It's not appropriate. So the most stable is copper 2 plus. So D, copper 2 plus, yes, in solution. It will need to gain back that electron to be reduced to copper solid or copper metal that will be deposited at the electrode. So in that case, D is the right equation for it. So D is the right answer for 34. D is the right answer for 34. Number 35. Number 35. The following equation give the half reaction for electrolysis of dilute sulfuric acid. Electrolysis of dilute sulfuric acid. Okay, dilute means that water is involved in it. Okay, let's go back again to our 35 for you to see better than what I was saying. Okay, dilute sulfuric acid. For dilute sulfuric acid, in dilute sulfuric acid, there is the anode and there is a cathode. That is question number 35. For dilute, it means water is involved. Sulfuric acid. So in water, we will have two ions. In water, we will have two ions. The two ions in water will be the hydrogen ion and the OH ion when it dissociates, when it decomposes. So the OH ion, there are two electrodes, the anode and the cathode. The OH ion will go to the positive electrode, which is the anode. And the hydrogen ion will go to what? Will go to the cathode, which is the negative electrode. Now, again, we have, that is water. Now we have sulfuric acid. When sulfuric acid dissociates, it will have hydrogen ion and it will have the sulfate ion. For that purpose, the sulfate ion will go to the anode and the hydrogen ion will go to the cathode. In this case, if you look at the electrochemical series, hydrogen among the anions, OH ion is the least reactive. OH ion is the least reactive. It is right at the bottom of the reactivity or electrochemical series. So it is the one that is going to be deposited at the anode. On the other hand, if you look at the list of cations, potassium ion is highly reactive. It is right up at the electrochemical series. Hydrogen ion is right at the bottom, showing that it is the least reactive. So it is going to be the one that will be deposited. But we are more concerned with the reactivity at the anode. The OH ion at the anode is the one that is going to be deposited. That is the one that is going to undergo the reaction. So the reaction now, the OH ion now, here, this is the one that will be deposited at the anode, and this is the one that will be deposited at the cathode. So at the anode, it is OH minus. What is going to what is going to happen? Now here, just from the sign, OH minus. So we need to oxidize this one. It is negative. We need to, the one need to undergo oxidation. It needs to undergo oxidation. So, in other words, it need to, this is the negative, OH negative shows that it has electrons in it. It has gained electron. So it need to give out the electron that it gained. That is oxidation. The electron need to lose those electrons. It has to lose the electron that it gained. So for them to lose this electron, what happened? This is the equation, oxidation. So it will be OH minus to water and to oxygen and 4 electrons. We now balance it. So it is undergoing oxidation. It is negative. You need to undergo oxidation. If it was positive, it will undergo reduction. Reduction is gain of electron. Oxidation is loss of electron. So it need to undergo oxidation. So going back to our answer column, question number 35, the equation represent dehydration. No. It represent hydration. No. It represent oxidation. Correct. 35 is C. Number 36. Electrical energy is produced by a simple cell as a result of ionization of the electrolytes. Simple. Yeah. Ionization of the electrolytes. You cannot say formation of negative ions. You cannot say transfer of electron from a reactive element to a less reactive element. You cannot say reaction of positive ions and negative ions. So our answer for 36 is A. Okay, 37. Consider the following electrochemical cell notation. We have zinc solid in solution. It will give out its electron. This implying that this one is undergoing, that is loss of electron, is undergoing oxidation. From zinc 0 to zinc 2, it's undergoing oxidation. Then on this other cell, this half cell, this one is undergoing reduction. Copper is, zinc will give out electrons, and these electrons are accepted by copper to become a copper solid. Then they're telling us the negative electrode is, the negative electrode will be where, the negative electrode will be where the reduction is taking place. For instance, let's this one here. Now, this is zinc. Zinc is giving out the electrons. It is easier for zinc to give out this electron because its electrode potential is very, very low. It's negative. So it's better for it to give the electrons, and these electrons are captured by the copper on the other cell to become copper solid. So the negative electrode will be where this one is taking place. The negative electrode will be the copper. That will be the copper rod or the copper ion. And that will be the cathode. So our answer for 37 will be C, copper metal. Or question number 38. Complete hydrogenation of benzene product. Hydrogenation of benzene, complete hydrogenation of benzene produces cyclohexane, margarine, and oil. Complete hydrogenation. Hydrogenation is the addition, in organic chemistry, hydrogenation is the addition of hydrogen into a double bond. Okay, let's look. This is benzene. This is a benzene molecule. This is a benzene molecule. If we should add hydrogen there, and this is facilitated by a nickel or a platinum catalyst. Either you use a nickel catalyst or you use platinum catalyst. When heated, the bonds, when heated, the 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 delocalized ring of electrons here, or the ring of electrons, or the delocalized system, a pi system, is broken. The benzene ring is broken when hydrogens are added onto the ring. So the first thing is there will be delocalization, or there will be breaking of distortion of the ring when this is being added. And the resultant will be a cycloalkane. So when we add this, remember benzene, we have only one hydrogen here. There are only 6 hydrogen there. Benzene is C6. Benzene is C6. That is 1, 2, 3, 4, 5, 6. And there are only 1, 2, 3, 4, 5, 6 hydrogen. Benzene is C6H6 because of the ring. But when the ring is being destroyed, we need to add other 6 hydrogens there. So this is, the result will be this one. Either you write it like this, the cyclohexane is like this, or you show out how the atoms are. This is how the atoms are. CH2, 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 CH2. Our result is a cyclohexane. A cyclohexane, that is 38. 38 is cyclohexane. And hexane, that is A. 38 is A. A cyclohexane. Now, which reaction is represented by the following equation? This is an alkene. Alkene is reacting with bromine. Alkene has a double bond. Adding bromine across a double bond will give us this compound. So the type of reaction between a halogen and an alkene is what we call addition reaction. So our reaction for 39 is A. 39 is A. Now, for 40, which of the following statement about protein and the carbohydrate is correct? Protein and the carbohydrate is correct. The statement about protein and carbohydrate is correct. Protein and carbohydrate. They are made up by condensation polymerization. Proteins, carbohydrate, and the proteins. Condensation polymerization. Remember that proteins are made up of is a polymerization of amino compounds, or organic compound containing the amino group. The amine group, when they come together with the release of a molecule of water, the resultant is a protein molecule. The same thing with carbohydrate. Carbohydrates are formed by a condensation reaction. So they contain same functional group? No, they do not contain. Proteins are formed from the functional group for protein from the amino group is NH2. But this other one is not like that. They hydrolyze to produce the same compound. No, when they are broken down, they don't produce the same compound. Carbohydrate is broken down to produce glucose. Protein is being broken down to produce amine. The amines, that's what made of the proteins. Amines or proteins are long chain formed from polypeptides. So hydrolysis, they are made from the same monomer. No. So the only statement about protein and the carbohydrate that is correct is that they are condensation polymers. Proteins are formed from amines. When the polypeptides they chain up, the resultant is always a molecule of water that is being released when proteins are being formed. Polypeptides are formed. When molecules of glucose they group up together, they form what we call the carbohydrate, which are the complex molecule. But a molecule of water is always but water is always released. So it's a condensation, they are all condensation polymers. So our answer for 40 is A. Condensation polymerization. 40 is A. 41. A group with molecular formula CH2O2 is a carbohydrate. Let's first of all write the molecular formula there, a group with this molecular formula. For 41, the molecular formula, this is the molecular formula. So you see okay, you see this hydrogen, single bond carbon, double bond oxygen, OH. We call this is an acid group. This is an acid group, but there's only one hydrogen there. There's only one carbon there. Because the presence of only one carbon and having an acid, a carboxylic acid group there, we call it a methanoic acid. This is a methanoic acid because it has only one carbon with a carboxylic acid group attached to it. So now, if we go to our answer column 41, a compound with the molecular formula CH2O2 is a carbohydrate, 0. It's a carboxylic acid. A carboxylic acid, yes. It's an ester, yes. No. It's an alkanol, no. Because it has a carboxylic acid group, we call it it's a methanoic acid, but it containing a carboxylic acid group, so we call it a carboxylic acid. So 41 is B. Question number 42. The reaction of an organic acid with an alkanol is known as A. Acid and an alkanol is known as A. Saponification, neutralization, hydrogenation, esterification. The answer is esterification. The acid, when an acid reacts with an alkanol or an alcohol, the carboxylic acid group will react with the OH group of the alcohol. A molecule of water is being released, and the bond, we call it an ester linkage bond, will be formed in between the two of them. An ester linkage bond that is being formed. The compound will now give us what we call an ester. An ester linkage bond is formed when a molecule of water is being removed from it. And the total compound is what we call an ester. In that case, that process of the acid, an organic acid reacting with an alkanol or an alcohol, is what we call esterification. So 42 is esterification, is D. 43. The IUPAC name for C2H5 COO C2H5. The International Union of Physical and Applied Chemistry has a systematic way of nomenclature of organic compounds. This compound is an ester. This compound is an ester formed from an alcohol and from a carboxylic acid. So let's write it out before you can name it. Okay, this is the from the structure. This is the compound. The compound initially was from the formula. From the formula the structural formula. The compound initially was, it is 1, 2, 3. The compound is a propanoic acid. This is propanoic acid 1, 2, 3. Propanoic acid was reacting with what? Was reacting with ethanol. That is a carboxylic acid and an alcohol. Propanoic acid and ethanol. As I earlier told you, the OH bond of the carboxylic acid will react with one of the hydrogen from the alcohol. Only the hydrogen of the alcohol is removed. And that gives us a molecule of water that is being taken away. So from this and that, a molecule of water is being removed. And from here to this one is being linked by this oxygen. This is what we call an ester linkage. So if that happens, this is going to be the product of it. Now, this is the propanoic acid I was telling you. A molecule of water has been removed. This linkage, the linkage here to this other one, this section, the whole of this section here, is what we call the ester linkage. So from here to this place is what we call the propanoate. And this other section of the alcohol, that is the alcohol of the alcohol, is what we call the ethyl group. There are only two carbons there. 1, 2, that is the ethyl group. If it was only one, we'll call it the methyl group. If there were 3, we'll call it the propyl group. If there are 4, we'll call it the butyl group. If there are 5, we'll call it the pentyl group. Now, here, noate is because of this oxygen. We call it propanoate. So in naming, according to the IUPAC system of nomenclature, you start naming using the alkyl group of the alcohol. You start with the alcohol first. Since the alcohol is an ethyl, has an ethyl group, we will call it an ethyl propanoate. Ethyl propanoate. If it was a methyl group, that is CH3, we'll call it methyl propanoate. If there were 3 of them here, 3 carbon atoms, we'll call it a propyl group. We'll call it propyl propanoate. So there are only 2, we call it ethyl propanoate. So the IUPAC name for the compound 43 and question 43 is ethyl propanoate. Ethyl propanoate. Ethyl propanoate. That is B. Ethyl propanoate. There are 2 carbons here. There are 2 here. 1, 2. There are 2 carbons here. So we call it ethyl. If there were 3 carbons, we call it propyl. If there's only 1 carbon, we call it methyl, as I said. Okay, ethyl here. 1, 2, 1, 2, 3. So that is 43 is B. 44. The final product obtained when cellulose is hydrolyzed using a dilute mineral acid is fructose, glucose, maltose, and sucrose. When cellulose is acid hydrolysis of a cellulose, the final product that we will obtain will be a glucose. It's glucose. It's glucose that we will obtain from it. That is B is glucose. When cellulose is broken down, we will have a glucose as the final product. We cannot have maltose. Maltose is a disaccharide. Glucose is a monosaccharide. Glucose is a monosaccharide. So when a disaccharide is broken down, we'll have a monosaccharide. Maltose is a disaccharide. Sucrose is a disaccharide. So 45. 45, the product of fermentation of sugar, that is C6H12O6, are ethanol and water. Ethanol and water. Ethanol is one of the products of fermentation, but it's not water, it is carbon dioxide. Ethanol and carbon 4 oxide. No, it is ethanol and carbon 4 oxide. Ethanol and enzyme. No. Carbon 4 oxide, and water. No. The right product here would have been answer A if it was ethanol and carbon dioxide. Ethanol and carbon dioxide is these are the products of fermentation of carbohydrate or glucose. So the answer provided by the examiner is somehow not really appropriate. Not really appropriate. When carbohydrate solution is being fermented, it is being fermented. It is an anaerobic. It undergoes anaerobic fermentation. In this case, the enzyme here, the biological enzyme here is found in the yeast. The biological enzyme is found in the yeast. So the yeast is going to act as a catalyst. The biological catalyst, sorry. The biological catalyst, which is the enzyme in the yeast, is the one to catalyze this reaction. And the reaction is usually at 37 degrees Celsius. I said it is anaerobic. It is under anaerobic condition. There's no oxygen in it. No oxygen should be involved. So under this condition, we will have ethanol and the carbon dioxide that will be produced. But the examiner has given ethanol and water. So I don't really know. The right answer, maybe in subsequent exams, please. The right answer is ethanol and water, ethanol and carbon dioxide. For this one, I will not tick because it does not comply. I will not tick this because it does not comply. It's supposed to be ethanol and carbon dioxide. Question number 46. The main impurity in hematite. The main impurity in hematite. Excuse me, please. The main impurities in hematite. Hematite is hematite. That is question number 46. Hematite, that is the ore where iron is being extracted. So iron is being extracted from the main ore, which is hematite. So the main impurity that is found there is silicon dioxide. It is silicon dioxide, which can now be removed using calcium oxide. When calcium oxide now reacts with silicon dioxide, we'll call calcium silicate will be formed. That will be deposited as in a molten state at the bottom. Okay, so our answer for this, the impurity found in the hematite, is B. That is B. 46 is B. Number 47. Iron is better protected from corrosion. Iron is better protected from corrosion by plating it with, that is protecting it by plating it with copper, with tin, that is 47, with tin, with silver, with zinc. From all investigation, iron is being plated. Iron is being plated with tin. Iron is better protected from corrosion by plating it with tin. It is better protected by plating it with tin. tin is the most appropriate answer. Plating it with tin. Some can use silver, but tin is more appropriate. Okay, 48. Which of the following metals is stored in paraffin oil? The metals that are usually stored in under paraffin are group 1 metals because they are highly reactive. Group 1 metals are highly reactive. They react vigorously with air and in water. So for that purpose, to reduce their reactivity with air, they better store them under a paraffin oil. And any of the group 1 metal that is stored here is sodium. So 48 is a right answer for that. 49. Steel is obtained from iron. Steel is obtained from iron by A. Alloying, B. Electroplating, C. Galvanizing, D. Roasting. The better way you can obtain like a steel, when we say stainless steel, all those things like that, is by alloying. We're mixing it with alloying, that is mixing 2 or more metals. So when we add steel with iron and we produce something like cutlery, all other things like that, we will obtain steel. So the best thing is when we add those 2 or 3 metals, we call it alloys. So by alloying, steel is obtained from iron. So alloying is the right answer. 49 is A. Now, ammonia is manufactured industrially from its element according to the equation. Nitrogen, which is a gas, plus 3 moles of hydrogen, which is a gas, will be passed through a particular substance W to give 2 moles of ammonia, which is gas. W represent vanadium 5 oxide or vanadium pentoxide. W represent B, manganese 4 oxide, W represents C, nickel catalyst, and D, W represent iron. Remember, in the industrial manufacture of ammonia from the 2 gases, nitrogen, that is taken from maybe nitrogen and hydrogen. These substances, what happened is that they are passed over a catalyst. We call it a finely divided ion. It's a finely divided ion that is being used as a catalyst. I think with under 450 degrees Celsius at a pressure of, I think it's 1 to 2 atmosphere. So with this, finely divided ion is the catalyst that is being used. And if they are telling us D is ion, so D is our appropriate answer. Then finally, I will give you a brief, some examples on how you can deduce the rate and the order of a chemical reaction from the concentration of the reactants. Thank you for listening. Before you go, if you haven't subscribed to our channel, please make us a favor by liking the video, sharing to other fellow learners, and most importantly, take some time and subscribe to the channel, because we are still going to be discussing or solving other past examination questions. When you do that, you will be receiving subsequent lessons. Thank you.